All right. Thank you to everyone who is joining this afternoon. Today's webinar is on our branded Soundmaster Dyno cells. I will be walking through, what goes into the proposal or the quotation, a little bit about the design, fabrication of some of the key components that make up the Dyno test cell, and then finally the installation. So let's get started. So who am I? My name is Karl Lee. I'm the National Sales Manager. Some of my background, I am an engineer. Started out as an engineer in automotive and aerospace for 13 years. And then I eventually migrated into a sales role with automotive, telecom, retail, and acoustics for the last 23 years and counting. What we're going to talk about today on the agenda is the proposal itself. So we'll talk about, how I take your sketches or our conversations and we put them into panel selection, and then finally the quotation that includes a couple of key components, which we'll talk about in design, airflow calculations, expected performance metrics, and then into fabrication, the panels, silencer, and the doors specifically. And then finally, I will go into some of the CAD drawings on the installation, the ease of installation, and a couple of examples of some of the completed projects that we've done. So the proposal, how do we typically start this process? I get this question a lot through email or phone calls. And quite frankly, it start with a hand sketch. These are actual drawings from potential clients like yourselves, and it can be a hand sketch on a napkin, or it can be something a little bit more CAD-like. But we'll talk through the process about the size of the room, some of the airflow requirements, silencers, doors, window, any type of lighting, switches, etc. So one of the most important things with a dyno cell, besides the structure itself, is determining what type of fan you will need for exhaust. Meaning, if you're doing an engine test or a chassis dyno or a motorcycle, whatever you're testing in the room, sometimes the equipment that you're using is sensitive to temperature increases, or you might have some exhaust that you certainly don't want to keep harmful gases like carbon monoxide build up. So what this table represents is it's basically an Excel spreadsheet that I use to specify a certain type of fan. And just an example here, if you're running typically up to say a 300 horsepower engine here, there is a direct relationship on how many BTUs per hour of heat that you'll have to dissipate. And so by looking at some of these metrics, we can appropriately size a tube axial fan to provide the air changes in the room that you might need. The other tool that I use typically is, what is the expectation with putting a dyno test room into the facility? How does that attenuate the noise? What can you expect to hear outside the room, if anything? And what this table represents is in the purple area here, you'll see all the different types of structures that you might be putting this room into. As an example, if it's a sheetrock interior or a metal panel, pole barn type of thing, any type of structural material that is existing is going to be represented on this table. And this is a critical metric to take the absorption coefficient associated with those types of materials, put them into our spreadsheet here, and with the dimensions of the room, we can determine approximately what type of attenuation or noise absorption that you will enjoy with our structure, and that's represented here in the red. So this is just a typical process that we go through before we actually get to the proposal part, which will be next. So We get through that process, which can take, anywhere from a week to 2 weeks, depending on, how the communication goes. I will put together a proposal, very similar to this, and I will spell out all of the items a la carte that will go into creating the structure, and in addition to the installation costs, which you'll see in the body of the proposal itself. So that way you can make sure that I've covered everything that you desire in your customized cell. And if we move beyond the proposal and it's accepted by the client, we'll typically go into a submittal process. The submittal process is where we generate CAD drawings for you before we even go to fabrication. So this is a critical step in the process, so that you know exactly the room size, the door size, the window size, panel size, to make sure everything checks all the boxes for this modular building to go into your facility before it's released for production. So the drawing here represents panels, which is the major component that constructs the roof and the walls of the building. I should mention the building is usually put on a flat concrete surface, and these floor channels are secured to the floor or the concrete, and the panels are modularly installed into the channel along with each joiner, which is a steel component, looks like an I-beam. And basically everything is using a self-tapping screw to secure everything in place. Doors, windows can be customized. There's really nothing standard. So some clients like double doors so that you can get your vehicle in. Some people like single doors that are a little bit wider than your traditional door. It just depends on what your needs are. Again, the final CAD drawings before they go out for approval and submittal process, you will see something like this in typical package. This is just really page 1. And in this drawing, you can see that we have silencers depicted on here on the exhaust and on the inlet side, or I'm sorry, exhaust and inlet side on this side, windows, panels, specific panel sizes. As an example, this is 48 inches by 120 inches. So this cell here would be a 10-foot tall cell. This would be your blower or your two-axial fan. We typically like to draw the air from the front of the car toward the rear if this is a pull-in type of dyno here. So you'll see all in detail of all the components that are fabricated to assemble to be one dyno test cell in your facility. So let's talk a little bit more about these individual components. As I mentioned, the modular panel, it is basically a fiberglass or rock wool insulation, usually about 6 pounds per cubic foot. That gives you the mass to absorb the sound that is reflected off the walls and ceiling. This perforated side usually is installed on the ceiling. We do have customers that want them on the walls, but it's really a preference. I think sometimes when you have some failure in whatever engine or chassis or your car, that's during testing, there tends to be some oil that gets on the wall, so people would prefer like a harder surface. So we can do both a harder outer shell and a harder inner shell, or a perforated inner shell. And then the second most important product is the silencer. And these silencer, again, are nothing standard. They can be made to any custom size. Lastly, the third most important part is your control door. Our doors come fully assembled, as you see here. The door and frame are completely assembled. The door is on its hinges, so you basically uncrate the door, and after the structure is built, this gets tipped up into the open space and secured with self-tapping screws installed very quickly. So, very important feature of quick assembly and performance. Now the installation. So if you choose to install it yourself, we provide very detailed drawings. This is just page 1 of how some of the components go together. So whether it be a roof support beam where you're putting the roof tiles, or if you're going to the door itself, there are very detailed instructions on how to do that. So if you choose not to do this way, we can also provide you with our installer, an accredited installer that can come out to your site and install it in a matter of a few days. A little bit more about how it assembles. So everything comes in a crate. Here you see tube axial fans. The panels that you see that make up the building, the windows, the doors, are all created and arrive at your facility and disassembled by our third party or by your own people. It's very easy. And the next slide, I would like to play a short 5-minute video that really goes through how everything goes together.
This year, we're upgrading our engine dyno, starting with the cell itself. First, the exhaust fan ducting was removed, and using a wet saw, a 4x5 rectangle was cut for the air inlet vent. Then the exhaust fan was pulled very carefully. The new exhaust fan is larger, so the exhaust outlet was cut to match the inlet, 4 feet tall by 5 feet wide. Finally, panel by panel, the old dyno cell was dismantled.
Questmark laid down their thin mill coating, which is a high-performance floor product that offers excellent abrasion and chemical resistance. The perfect choice for a dyno cell. They finished it out with decorative flake and cleared it with a semi-gloss top coat. Tons of cool packages show up on our loading dock, and this is one of the coolest. The Soundmaster dyno cell arrived carefully packed in a rather substantial shipping crate.
So once you receive your test cell, you can uncrate it, and you're going to start with your floor and your foundation. Once you have the floor channel down, that's already pre-cut, all of our products and materials are pre-cut and pre-assembled where they can be. You're going to level up your floor track, and then you're going to start your construction with the panels. And it's really a good modular package where we give you a full set of design drawings. Prior to us creating your test cell, you actually get to approve your test cell.
With the track installed and leveled, the wall panels drop into position. They are only 4 inches thick, but perform comparably to 8-inch thick concrete block filled with sand. The panels have an STC 50 rating. The sound level outside the dyno cell will be roughly 40 decibels quieter than the level inside during engine testing. More important, the panels, doors, and walls are ballistic rated to protect operators and observers in case of major engine failure.
Engines do come apart. It's just reality. The test cell is going to be double wall construction. Typically in the engine dynamometers, it's going to be a hard interior wall, hard exterior wall. That can capture a lot of objects, things that come apart in the engine.
Because the test cell is modular, it can be manufactured in about 3 weeks, and noise barriers can install the cell in just a few days. Also, it can be modified or even moved to a new location if needed. We had a special request for our dyno in the form of an oversized door in the side of the test cell. We wanted plenty of room for engines and production gear, and an oversized window to give us another angle to observe the engine during dyno runs.
This was actually built specifically for you guys, so you're kind of the first to get this size. It's hopefully something we'll have in the future for a lot of other customers, because I'm pretty impressed with it. It's a 6-foot wide by 7-foot tall door. It's a single leaf door, which is obviously unique in that for the dyno test cell.
The inlet duct brings in fresh outside air, which flows across the top of the engine to keep it cool during testing. Here's a look at how the air flows through the cell.
The test cell has a plenum with a powerful fan that draws in fresh air and evacuates heat and exhaust gas through an enclosed exhaust stack. Thanks to an exhaust fan which moves 30,000 cubic feet per minute, the system exchanges all of the air in the room 10 times a minute or more. Beyond the exhaust fan is an industrial silencer which reduces the sound level transmitted to the outside air.
In this test cell, we also have an air inlet silencer that's designed for your combustion air. You can draw your combustion air directly from your shop, which is a much more consistent location to draw your airflow from.
And with the test cell all buttoned up, we'll turn our attention to the dynamometer.
All that's left now is to make the first dyno run with our new setup. Okay, so right away, noticeably quieter. you like by a bunch.
That's
Much
great.
quieter.
Usually when we start the engine, a bunch of people will come running back because they know we're running, so I kind of like that we're a little bit more secretive now.
You can always open the door and fire it up. They'll come
Yeah,
back.
all right, you guys ready?
Let's do it.
All right.
Make some noise.
I think now that we have a running dyno, we're going to make some power. So
Now
thank you.
it's time to go in there and make more.
It's time to go in there and make some more. You're right, man. Thank you very much. I'm going to fire it back up.
For more information on anything you've seen today, visit PowerNationTV.com.
Okay, thanks for watching the video. I think a picture tells 1,000 words and a video tells 1,000,000 words, I hope. Let's skip over that. It's like it actually did play. All right. So just to finish up, I have a couple of examples of some finished product. We custom paint, obviously here. This is a chassis dyno. We can do custom doors. This is not your typical standard double leaf door. This is much wider. It's probably a 8-foot wide by 7-foot tall door, as an example. So very, very custom features, as well as the plenum itself, a painted plenum to match the enclosure itself. And then second example is windows. Nothing standard again. If you want to go the custom window size, we can accommodate that. If you want a bullet resistant glass, we can also include that as well. And my last example, as you can see, this is for Harley Davidson. This is a motorcycle dyno test cell, custom paint job with Harley Davidson here. Heavy duty front doors here. The outlet silencer here, as you see, is custom painted to their colors. So really, the sky's the limit on how you want to customize your product. We can certainly make it happen. Appreciate your time. Thanks for watching the webinar this afternoon. If you have any questions, I can provide links to the YouTube video that you saw. Just email me at the email you see there, kaylee@noisebarriers.com, or call me on my cell direct. Thanks again. Have a great day.